All right, let's jump right in. Today, we're going beyond the basics of Pyspark. We're talking about the real-world, practical patterns that senior data engineers use every single day. The kind of stuff that actually gets you hired and makes you effective from day one.
The game has really changed. As data engineer Ansh Lamba points out, the bar for Pyspark skills is just way higher now. Just knowing how to do a simple group by, that's not going to cut it anymore. The whole level of expectation has been raised. So what do they want to see? Well, today, interviewers and your future team leads, they're going to throw messy, real-world business challenges at you. They want to know if you can apply these sophisticated patterns, not just if you've memorized a few functions.
So that's the big question, right? Are you ready for this new reality? Well, stick with me, because we're about to arm you with the patterns and techniques you need to not just pass the interview, but to become a seriously valuable data engineer. Think of the modern data landscape as a new kind of battlefield. Yeah, it's more complex, no doubt about it, but it's also where all the most interesting work happens. And to win here, you need the right set of tools. Let's kick things off with a problem you will face constantly. Data that just won't sit still. It's always being updated, corrected, and added to. So how do you handle that chaos without messing up your tables, or even worse, losing critical historical info? The old way was, let's be honest, pretty clumsy. You would either just overwrite the entire table, which is super slow and costly, or you'd append every new record, which just creates a giant mess of duplicates. The modern way is so much smarter. We use patterns like an upsert to intelligently merge in changes, and something called slowly changing dimensions, or SCDs, to keep a perfect record of how data has changed over time. Okay, now this is absolutely crucial. The logic behind a proper upsert or a merge isn't just about matching an ID. Pay close attention to step 2 here, the condition. You have to check if the incoming record's timestamp is newer than what's already in your table. Why? Because this one little check prevents a total disaster during backfills where old data could accidentally wipe out your newer correct data. This is a pro-level move. But hey, what if you don't want to overwrite data at all? Well, in data warehousing, we have these things called dimension tables. They describe our products, customers, stores. You get the idea. What if you need to know what a product's price was last year? That's where SCD Type 2 comes in. Instead of updating a record, you just preserve the old one and create a new one. It gives you this perfect historical timeline. And this timeline shows you exactly how it works. See, in January, the product costs $100, and it's marked as active. Now, watch what happens in June when the price drops. We don't just change the number. We go back to that original record and we retire it by setting an end date. Then we insert a brand new record with the new price, and that becomes the current active one. History is perfectly preserved. Nothing gets lost.
All right, so we figured out how to handle data that's always changing. Now for our next big challenge, data that comes in all sorts of complex shapes and sizes. Because trust me, it's rarely simple.
Yeah, modern data sources. We're talking APIs, event streams from Kafka, data from mobile apps. They love sending data in formats like JSON. Think about an online order. You've got one order ID, but inside that order, you've got a list of items. And each item has its own price, its own quantity. It's a classic nested structure, and it's something you'll deal with all the time. So how do you wrestle that into a nice, clean table? Well, Pyspark gives you 2 main weapons. For nested objects, like a customer's address, you just use simple dot notation to drill down and grab what you need. Easy enough. But for arrays, like that list of items in an order, you use the super powerful explode function. This thing takes each item in that array and creates a whole new row for it. So if an order had 3 items, boom, explode gives you back 3 rows. It basically unpacks the complexity for you. Okay, we've talked about solving specific problems, but what really separates a good data engineer from a great one? It's not just about finding a solution. It's about building solutions that can be used again and again. And that brings us to reusability. You'll find yourself writing the same logic over and over again. For deduplication, for handling nulls, for data validation. Instead of copying and pasting code everywhere, a pro bundles that logic into a Python class. This is a total game changer. It means everyone on your team is doing deduplication the exact same way. It means you can fix a bug in one place, and it's fixed for the 100 pipelines that use it. In your main code, it becomes so much cleaner and easier to read. You're not writing one-off scripts anymore. You're engineering a system. So, we've covered a lot of ground here. Let's pull it all together and build out your modern Pyspark toolkit. Here are the big ones, the key patterns you need to master. First, the upsert, with that critical timestamp check. Second, understanding SCD Type 2 to build rock-solid historical tables. Third, getting really comfortable with flattening complex JSON. And finally, start thinking in terms of reusable classes. It'll make your work scalable and so much more professional.
Look, these aren't just abstract theories. These are the building blocks for creating robust, real-world data pipelines. These are the solutions to the problems you're going to face every single day. So the only question left is, now that you have the blueprint, what are you going to build?